Today we're talking about perspective, but we're going to focus on the mechanics of planes, and hopefully we'll get somewhere interesting. So if you have a plane of any kind that you're just looking at flat, so this is just facing you. No part of it is further away than any other part. So if we want to find the middle, we can just measure it, right? We can find the center just by measuring it, whatever. But it's also true that if we draw lines from the corners, where they intersect will automatically give us the center and the halfway. Now, we just took this box and broke it up into 4 parts. And if we wanted to continue doing that, and to make it smaller, now we do that to all of them, we can break it into eighths. And that needs to be a little further over. And then if we do that again, we can break it into 16ths and so on. So that's just an illustration of how this works. But if we, let's say now that we have a 1-point perspective box, and our eye level is way up here. Okay, so that's a nice messy box. We cut it off. Now, I showed you this in the ellipse video briefly. But I want to go into a little bit more detail. So if we have a plane now that's not facing us, it's moving away from us in space, there's a lot of utility in being able to find halfway. And I'll show you a couple different things that sort of flow from that once we get some of this stuff down. So if we, again, if we, let me get the x's done. Okay, so just like the flat plane that's to us, if we just take the horizontal and measure it, because remember, 1-point perspective, neither one of the corners is closer to you. If we just measure halfway here, it's the same at the bottom and whatever. But the question is, how do we get the halfway point in space with these lines that are moving away from us? And the answer is the same thing we did here. We do the x. So you just draw lines from the corners where they come together. That line goes back to the vanishing point too. And what we end up with is the halfway here is easy enough to find. But when we go and do the horizontal here, we get the front half is bigger than the back half. And that's true because things that are, if 2 things are the same size, and one is further away, the furthest away one ends up being smaller. And that's a truism. That's kind of one of the main effects that perspective captures. And one of the cool things about perspective is that if you get one thing right, you can usually just plug the perspective in, and the other things will be right too. So if we wanted to subdivide this further, just like we did here, it would be easy enough. If I could stand in front of the paper, it would be a lot easier. From there, we'll go back to the vanishing point. Forward. So now we have quarters, and now we have eighths. So we just do the same thing over here. We end up with subdividing the plane. Now, if you're drawing like a chessboard or Monopoly, like a board game, which is something that we'll do in the class, there's all sorts of utility for being able to break up the plane into multiple even sections in space. All right, so let's go and do the same thing in two-point perspective. So if we have a front corner, and then our eye level is up here. Trying to make what amounts to a cube. So far, so good. These are getting kind of messy as they go further out, but I got things in the right places. Okay. Okay, so now if we do the same thing, I'll start with the top here. If we want to do the same thing here, all we do is draw a line from the corners, and then what I do is I start from the center, because like here it's just like a plus sign as opposed to a multiplication sign. So here you just go to the vanishing point, it's straight up. But here, the vanishing point's over there and the vanishing point's over there. So what I do is I start from the middle and I draw my line all the way out and make sure that it's nice and straight. And it should be in between these two, leaving the page in a place where it converges with all of those. And then once you get it right, you just drag it forward. And then you do the same thing here. You go from here back to the vanishing point. And then when you get it right, you drag it forward. And what you should end up with is a situation where the front half is slightly larger than the back half. And that's good. And that's good. And it's not 100% precise. But the mechanics are okay. I'm not sure if that's a square or not. I guess we'll find out. But, okay, so we can subdivide this if we want to, just like we did before. Now from here, you go to the vanishing point. And I've got so many lines here, I'm pretty confident that I don't have to go all the way back in order to get that right. But these inside lines, you've got to make sure they go to the vanishing point. I see people so often, they do everything right, and then the line that is supposed to go to the vanishing point, like all the other ones, will do this, and it just totally messes everything up. So here we can break this from quarters into eighths, and so far, we can go all the way down. So that's how you break it into what amounts to an even number, but I want to show you another move that is going to enable you to break or to build increments in whatever number of increments you want. So instead of doing a whole box over here, I'm just going to show you a plane that goes off in the distance. So we'll have it be a little bit closer. All right, so that line is really thick. Tighten it up.
Okay, so if you have a plane going back in space, and you decide that you have an increment, okay, so that's our increment. What you do is if you're drawing like a Roman temple, let's say, and you have an odd number of columns that you want to try and build, you divide it in half, just like we did, and then you go from here back to the vanishing point, and then you go from the corner to the half mark, and you just draw that all the way through until it hits here, and then we have a new increment. Now, this is now, like, here, let me draw that. So now we have two equal distances. We started with this one. Now we know that in space this one is the same distance as that one, but in space it looks smaller. And then we just, now we don't need to cut it in half again because we already know where halfway is. As long as this line is good, it looks like it's a little low, or a little high. Make that a little more precise. So we want to keep going. And we get three of these increments down. Do that, go up. That. Go up. And we can do this forever until it gets so small that we can't see what we're doing. Now one thing that's worth pointing out that I think is kind of cool, and I used to do this, this is the proper mechanical, technical way to do it. I used to do it a different way, and the way that I used to do it is kind of showing up here if you just follow it out. If you follow these lines all the way out, I'll do this one, and I'll do this one. See how they're converging? All four of them are converging on a vanishing point that's just down here somewhere. Which is interesting, and three-point perspective is something that we'll have to talk about in some detail, but three-point perspective has to do with a vanishing point that's either at your feet or way over your head. So the last thing I want to talk about in terms of the utility of cutting a plane in half is it allows you to integrate ellipses with a greater amount of accuracy. So I'm going to go back to the one-point perspective thing and show you that. And then I'll play around for a little while and we'll speed the thing up. But remember, if we're drawing these boxes in one and two-point perspective, if we're making them transparent, remember how to do that? You just go from the front corner back to the vanishing point. Back to the vanishing point, we take these back lines and drop them straight down. And then they should hit, these lines should crisscross in the same place on both sides. Okay, so you can see that top plane, you can see that bottom plane, and look how, if we do it right, the bottom plane should be bigger, just like we talk about all the time with our ellipses. If you're at the eye level, an ellipse is just a flat line. As you get further down, the ellipse opens up. But it's not just ellipses where that happens, it's all planes. As long as they're parallel to the ground plane, that's an assumption that we make with all of this. That works out. So now we have a top plane and a bottom plane, and I'm going to put an ellipse in here. But I'm going to start with the bottom plane because it's bigger and you'll be able to see it better. Alright, so there's our line going back. Here's our halfway. And so if we're going to plug an ellipse in here, these are the points where the ellipse touches the edge of the box. So let me fill this in. Make sure I'm not in the way of the camera. I'm going to start like this and then I'm going to clean it up. Some people find this to be a lot easier. I've noticed that students have a lot of trouble with getting the ellipse to fit and not be too small. But just take your time. Make a mess and clean it up.
Okay, so you can see how that works. It looks like it might be a little lopsided, but I'm noticing that paper is too. So I'm going to use some more. But you get the basic idea. And then the same thing here. Those are the places where they connect. Draw my ellipse in. And you'll end up with a pretty good cylinder after this happens. Now, for some reason, when you do this in one-point perspective, it's really important your vanishing point is smack in the middle. If it's a little bit off, it distorts everything and gets weird. And I don't really know why, but that is just what happens. this sort of reinforces the idea that your ellipses are symmetrical. They should be the same, exactly the same on both sides. And sometimes that's what the structure's for. But I like the idea of doing ellipses this way, even though it's a ton of work to get here, because it reminds you that the front half of the ellipse is bigger than the back half, and it reminds you that it's a plane going back. Now we can do the same thing in two-point perspective. Drop that down. This guy goes back. All right, so I'll do a quick ellipse up here just because it's already ready. Putting it into two-point perspective is a lot trickier. There's a lot more can go wrong in a two-point perspective box. But you just got to make sure you fill it in. All right. And even though this box is twisted and rotated, the ellipse should look just like this. I start you here because it's not twisted at all, it's lined up, and the ellipses always look the same as long as your distance and your eye level don't change. In two-point perspective, it's a little bit trickier, but what you're shooting for is an ellipse that's based on a horizontal here. And for the most part, it looks like I'm gonna get there this time. All right, go back here. Tighten up that edge. So we've got a fairly decent cylinder over here.